I am the professor, the one professor in this castle who goes by the name of Julius Sumner Miller. And my business is physics. And are we not agreed that these matters are enchanting for the spirit, curious for the mind, exciting to contemplate? Let us now go to the ball on the string. And would you believe it? It is good for 6 one-hour lectures, but I shall dispose of it in a rather superficial way. Ball on a string. I need to make clear the following. Here is the circular path. There is the ball. There is the string. There is my hand. Let it be going in this direction. So, in a vertical circle in a vertical plane. At the instant in question, the ball is going this way with a certain velocity v. And in order to constrain the ball to the path, I have to exert a force on it, which we call the centripetal force. And if there is a pull of the string on the ball, there is a pull of the ball on the string, and we have shamefully labeled this one the centrifugal force, which gives everybody the idea that there is a force radially outward on the ball, which there ain't. Now, that may not be the King's English, because when I let go of the string or cut it there, that force disappears and the ball goes that away according to Newton's laws of motion. Now, an interesting inquiry, and you must be sharply tuned to my question. Is it not true that if I don't go fast enough, the ball cannot make the circle? Yes, it's true. Roughly shown like that. The ball can't stay up there because the string cannot take a compression. So I have to go fast enough for the ball to make the circle. For those of you who know some mathematics and some physics, and there are those amongst you, the critical velocity for this to happen is the square root of gr, where r is the length of the string. So if the string was 2 feet long, g is 32 without the units, the square root of 64, the ball would have to be going 8 feet per second in the path for it to stay there. Anything less, it'll fall down. Good. Good. Since this bucket is too heavy for me, I'm a weak professor in this old place. Let us imagine that this is the bucket and I have some water in the bucket. So I say, do you see that I have some water in the bucket? And people say, there is no water in the bucket. Ho, ho, you trouble me. I say there is water in the bucket. And for this purpose, we need imagination. How many see that I now have water in the bucket? All of you. Indeed, it is so. So there's water in the bucket, and there's a string connected to the handle of the bucket, and now, here I am, Mama. Look how big and strong I am, even at my old age. And obviously, if I don't go fast enough at the top, the water will fall out of the bucket. Are you not all agreed with that? Sure you are. And those of you who agreed with that are wrong. You say you are wrong. Why are you wrong? Because the bucket will fall with the same acceleration as the water in it, and the water will not fall out of the bucket. And now you can rest with your sick judgment earlier made. How many of you see that the water does not fall out of the bucket? It does not. It does not. And that is a beautiful little dilemma. So remember, the case of a ball on a string leads to an apparent paradox to which many fall victim. Many fall victim. In another program, I will show you another one bearing on this matter. So beware, beware. I shall come again.